Hello. In this video, we will discuss representing graphs. Representing a graph is to store its vertices and edges in a program. There are many different ways and use different data structures to store a graph. We will discuss most of the common approaches for representing a graph. First thing is, how do you represent vertices? The vertices can be stored in an array or a vector. For example, you can store all the vertices in the graph in figure 26.1. So this is the graph with cities and the edges connecting the cities. We use an array of strings for this vertices. So these are the vertices: Seattle, San Francisco, Los Angeles. And you can use any type for the vertices. So this is a string. You can use a class type. Here is the custom class type, a city. So this is city here is the class, and you can construct the city. So these are the functions in the city class. So the city objects are created using the city name, population, and the mayor for the city here. So these are the cities, and you put all the cities in the array. So you can also use vectors. Vectors actually are better because it's more flexible. So in the program, in the next video, we will use a vector to store vertices. So these are the vertices here, and the you can use a vector. The syntax for the vector is very similar to array. So you have this, assume this vertex is a vector. You can have this vertices bracket 0. So this is Seattle, brackets 1 is San Francisco, and so on. All right, so now let's look at representing edges. Many different ways can be used. So let's look at the first simple way here is using an edge array, a two-dimensional array. So here is, you have the two-dimensional array, and inside this array, you have each element is a one-dimensional array with the indices of two vertices. So 0, 1, so that's 0 is Seattle, and 1 is San Francisco. So this is 0, 1, and so 0, 3. So look at this is 0, 3. Now, if this is undirected graph, so you need to have both sides. So 0, 1, and also there's a 1, 0. So this is the edge array to represent edges. Now let's look at representing edges using edge objects. So we define this class edge. This has this two data fields, UV, and so you create an object. And you can now push this object to the vector. This is the edge vector, and push it to the edge vector. Representing edges using adjacency metrics now. This is the adjacency metrics. So this is the, you have this 12 vertices. So this is 12 by 12 matrices. And this is the, from Seattle to San Francisco. So here is from San Francisco to Seattle. So this is, if there's edge, and you put a 1 here between these two vertices. So let's look at the representing edges using adjacency lists. So you're going to have this is the the neighbors, is, this should be a square brackets 12, it's array. So this is array, each element is a vector of int. So here, neighbors bracket 0 has this, the vector contains 1, 3, 5. So this is all the indices for the vertices that are adjacent to vertex 0. So that is to use this adjacency lists. Now we can use, this is another one here, is the for the instead of using this indices, you can use the edge objects. So this is the neighbors here. This should be square brackets 12. So you have this, the array with all this. Each element in the array is a vector consisting of the edge objects. So here is edge 01, 03, and this is 05. And for this, this is all the edges adjacent to vertex 0. Now we can use vectors instead of the array. So this is the neighbors 12 here is, this is the vector, and each element in the vector is another vector. So here for the neighbors bracket 0, you're going to push back here. This is the new edge. So that is for the all the edges adjacent to this vertex 0, and this is for the edges, all the edges adjacent to vertex 1. So this is more flexible. We're going to use this for our program is using a vector of vectors. So this is more flexible, and for adding edge, for adding vertices. So that is what we're going to do, is instead of using array. That is all for the representing graphs in this video. See you on the next video.